Circles, circles, they're everywhere. All right, let's talk about some more circles. All right, a little recap of yesterday. We talked about central angles, intercepted arcs, and then diameters quite a bit. So if we are asked to find the measure of angle ERA, that means I start at E, go to R, end at A, that's this angle here. Well, I can do that a couple of ways. One, I might notice that I have vertical angles, right, which would give me 50 degrees. Or I might notice that this side right here, or this segment, excuse me, is a diameter, and a diameter will cut the circle in half, which means it'll be 180 degrees. So I know that these three angles have to add up to 180. So if I take 180 and subtract 100, and then subtract 30, that leaves me with 50 degrees left over. So again, we could use the straight line, or we could use the idea of the semicircle, right? If we found the measure of the outside, measure of the arcs. Or we could also notice that this particular picture had vertical angles. And not every picture will have vertical angles, so you have to be careful and make sure that they actually are, in fact, vertical, which those ones were. All right, arc CE. Now, when I go from C to E, I notice there's point D here. That doesn't matter, right? If it's two letters, I'm going to go the shortest way. And the shortest way from C to E is to go through D. But if it's two letters, it's going to be the minor arc, so the shorter way. And I know that the measure of the arcs will be the same as the measure of the central angles. So if this arc is 100, that means that if this angle is 100, that means that this arc right here is 100. And if this angle is 30, that means that this arc is 30. So if one of them is 100 and the other one is 30, we know that the measure of the entire arc CE is 100 plus 30, or 130 degrees. All right, if we use three letters, we have to go through the middle letter. So it's C again, right? CBE. So I'm going to start at C. I'm going to end at E, but this time it says I have to go through B. So I'm going to start at C, go through B, and then end up all the way over here at E. All right, well, I know that the minor arc was 130 degrees. And then this is the major arc that goes with that minor arc. So what does the measure of this major arc have to be? Absolutely, it has to be 230 degrees. And a quick way to do that is if we already know the minor arc is 130, we can take the full 360 degrees in a circle and subtract what we already had in the minor arc. And that'll give us what is left over, which would be 230 degrees for that whole major arc. All right, the last one, angle ARB. So from A, R to B, so this angle here. Again, I have lots of ways I could do this. I know that I have a diameter here. All right, so actually, I'll go ahead and do it this way. This is a diameter. I already have 50 degrees, and so to get the rest of that half circle, or get the rest of that straight line, I can take the 180 degrees that I know there should be, subtract the 50 I already have, and that leaves me with 130 degrees. Is there more than one way to do that? Absolutely. I could use the fact that I already know everything except for this angle, and I could start with 360, subtract 50, subtract 30, subtract 100, subtract 50, and I would get 130 degrees. I could have used this diameter and this semicircle, but regardless of which way we did it, there is 130 degrees in that angle. All right, from central angles, we then moved on to inscribed angles, which is where the vertex of the angle is no longer at the center of the circle, but it is on the edge of the circle. And our key fact about inscribed angles, is that they are half of the intercepted arc. or the intercepted arc is double the inscribed angle. Okay, so this first one, angle ADB, that's this angle here. Well, that is an inscribed angle, which means it will be half of the arc that it forms, which if I go to A and B, that's this arc here, right? And so we know that this angle will be half of 76. So the measure of angle ADB is half of 76, or 38 degrees. Okay, sometimes we have to work backwards. For the second question, I'm asking us to find the measure of arc DC. But this time we're starting with the angle. Okay, and are inscribed angles the same as the arc? No, they're not, right? Central angles are the same as the arc. So if I know the inscribed angle is 45, I do know that arc DC will be different. And let me ask you, how many degrees will be in arc DC? Yes, 90 degrees. All right, we know that the inscribed angle is half of the arc, which means it takes two halves to make a whole. So if I take two 45-degree angles, or two sets of 45, right, add those together, I get 90. I could always double check as well. I know that this needs to be half of 90, so if I cut 90 in half, I do get 45. So the measure of this arc, 90 degrees. All right, I threw this problem on here because sometimes it tricks students a little bit. But the key idea is I know I have an inscribed angle. I know the inscribed angle will be half of the arc that it forms, right? So half of its intercepted arc. So 95 is half of 190, right? Or I can work backwards, I just double it. So 95 times 2 is 190 degrees. Well, then the rest of this is pretty simple. I know that 18x minus 8 is representing the measure of the arc. I just determined that the measure of the arc was 190 degrees. So now I can just set 18x minus 8 equal to 190. And from there, we can just go ahead and solve. Add 8 to both sides. Divide by 18. And I get x equals 11. That does not mean 11 degrees. It just means that if I plug in 11 right here, 18 times 11 minus 8 will give me 190 degrees. Okay, one more example based off of what we did yesterday. Find the measure of the arc. So I'm trying to find the measure of this arc here, which if I take this side and extend it, right, and I take this side, I know that this angle here is an inscribed angle of that arc. Okay, and again, I know that the inscribed angle will be half of the arc. But right now I don't know either of them. But I do know some facts about a triangle, right? So if this angle here is 54 degrees, this angle here is 64 degrees, we can now find the measure of this angle here because a triangle always adds to 180. And I get that this angle is 62 degrees. Okay, if we know the inscribed angle, we can now find the measure of its arc because we know that this will be half of the arc, or if we times it by 2, we will get the measure of the intercepted arc. So 62 times 2, 124 degrees. So these problems, even though that looked maybe a little intimidating at first, we know plenty of facts about different shapes, and we know facts about the inscribed angles and the arcs, and we can just work our way around until we have the piece we are trying to find. All right, consider the picture below. Let's come up with a way to find x plus y Z. All right, well, if I go to X, which is this angle here, I notice that it is an inscribed angle. Okay, so I'm going to go mark the arc that the inscribed angle is forming. So if I take the side, it hits right here. And then if I take the other side of X, it hits right here, which means the arc that it forms is this arc. Okay. And then if I go to angle Y, I notice it's quite a bit smaller, right? But if I extend the sides, it goes to this point. And if I extend the other side, it goes to here. So if I draw that arc, that's its intercepted arc. And then if I go to angle Z, and I extend the sides for angle Z, I notice that it forms this arc right here. So if I take those three inscribed angles and draw their arcs, what did their three arcs form? They formed the entire circle. Okay, well that tells me something. Because how many degrees are in a circle? 360. And then what do we know to be true about every inscribed angle compared to its arc? The inscribed angle will be half of the arc. So if the arcs, in this case, the arcs of X, Y, and Z all add up to 360 degrees, right? They form that full circle. What will the three inscribed angles have to add up to? Well, since inscribed angles are half of the arc, we can take that 360, cut it in half, and I now know that these three inscribed angles, when we add them together, have to add up to 180 degrees. Which, hey, that makes sense because those three angles formed a triangle. And triangles always have 180 degrees. Anyway, good times. Okay, changing topic a little bit, we're going to look at cyclic quadrilaterals. Cyclic just basically meaning circular. And in this case, all four of the angles are going to be inscribed angles, right? They're all right on an edge. Okay, I don't know any of their measures, but I do know that they are on the edge of the circle, so they're all inscribed. And so I'm going to find a way to figure out the different measures, but not on this problem. This is just a picture of what a cyclic quadrilateral is, and all four angles of the quadrilateral are on the circle. That's all it means. Okay, so now we have a cyclic quadrilateral, we have some information, and we're going to find the measures of some missing pieces. So when I go to angle X, I notice that the arc that it forms, right, if I extend the sides, goes to right there, goes to right there. I notice that the arc that it forms is pretty big. But then I also notice that if I go to the angle across from it, right, so I'm looking at these two angles that are across from each other, if I find the arc that goes with this inscribed angle, that's the other half of the circle. So if I think of this green arc as a minor arc, this blue arc would be the major arc. And together they form 360 degrees. So if those form 360 degrees, what will the two inscribed angles that formed that 360 have to add up to? Well, inscribed angles, as we've talked about, are half of the arc. So if we cut that in half, that means that these two angles right here have to add to 180 degrees. Because together, the arcs of those angles form the full 360. So long story short, to solve for x, I can just do 180 degrees minus 110, and I get that x has to be 70 degrees. Okay, so then you might be able to figure out, well, if those two angles across from each other formed a full circle, what's going to happen with these two angles that are across from each other? Well, let's check. If I take this angle here, and I extend the sides, it forms this major arc, which I'm going to color in red. If I do the same thing with this inscribed angle, and I extend the sides, and I draw that arc, I now have a complete circle. So these two inscribed angles that are across from each other, their arcs form the full 360, which means those inscribed angles have to add up to half of that. They also have to add to 180. So if we know that one angle is 148, the other one will be 180 minus 148, which is 32 degrees. So the measure of y, 32 degrees, and the measure of x was 70. All right, if you're a little lost on this, I promise we're going to make it make sense real quick here. So the key property of a cyclic quadrilateral, if we have a four-sided shape inside of our circle where all four of the vertices are on the edge of the circle, then the opposite angles are supplementary. And why are the opposite angles supplementary? Well, they're supplementary because their arcs make a full 360 degrees, and inscribed angles are half of their arc. So if we know that together the opposite angles form 360 degrees, we know that together they add up to half of that, which is 180. So now that we know that, we can look at this picture and solve this very quickly. You have a Khan Academy that's on this as well. It's very short, as long as you've made this connection. But if we take the angles that are across from each other, they will add to 180 degrees because their arcs form a full circle. So we can do 180 minus 86, and I get 94. So the measure of angle A is 94 degrees. And then we can do the same thing to solve for F. How many degrees will F be, or angle Z? How many degrees will this angle be? That's right. We can take the 180, subtract the opposite angle, and that gives me 71. So this angle here is 71 degrees. So again, when you have that inscribed quadrilateral, the opposite angles are supplementary. All right, one more of these. We know that this angle is 93 degrees. So if that's the case, what's the measure of angle A? That's right, 180 minus 93, 87 degrees. And while we're at it, if this angle is 44, what is the measure of angle D? That's right, 136 degrees, because we know those opposite angles will be supplementary. So if we subtract 44, that gives us 136. All right, last thing, just to introduce the vocabulary. We're going to do a lot more on tangent lines in our next lesson, but Tangent line is a line that intersects a circle at exactly 1 point. So here is a tangent line. It's touching the circle right here. That place where it touches the circle is called the point of tangency, right? Point, singular, one spot where it touches. And the key fact about this that we're going to use to solve lots of problems in our next lesson is if we have a tangent line and then we draw the radius that goes to that point of tangency, we get a right angle, which is going to lead us into lots of problems we can solve using right angles. All right, Titans, for today, that's all. See you later.